So I'm going to be teaching the skill I can graph a rational function to show key features, and the key concept of this is finding key features by looking at a graph. So the first graph I'm going to do is x minus 2 times x plus 1 over x minus 2 times x plus 5 times x minus 3. So first you're going to look for the x-intercept, which is the point or points at which the function touches the x-axis. So to find this on a graph, you just look where the graph touches or crosses the x-axis. And that, in this case, would be right here at -1, 0. Then you're going to find the y-intercept, and that is the point at which the function touches the y-axis or crosses the y-axis. And in this case, you're just going to look where it crosses the y-axis, which is at 0, -0.067. And then you're going to find a hole, which is where the function has a break, or where the x value, where the y value is undefined. So because the numerator has a shared factor with the denominator of x minus 2, the hole is going to be at 2, so then you just look where the graph has a value of 2, and as you can see, that is right there. So then you're going to find your domain, which is all of the x values of a function. So first, the domain starts at -infinity, and it goes to -5, but it does not touch -5. And then it goes from right next to -5, and it goes to 3, but does not touch 3. And then it goes from 3 to infinity. Then you find your range, which is all of the y values in a function. So the range starts at -infinity, and it goes to 0, but does not touch 0. Then it goes from 0 and goes to infinity. And you're going to find your asymptotes, and the asymptotes are lines in a function that the function reaches but doesn't touch. So first you're going to find vertical asymptotes. In this particular one, there are 2. The first one is x equals -5, and you can see that by looking where the graph reaches but never touches. And here the graph goes towards -5 but never actually touches it. And here the graph goes towards -5 but doesn't actually touch it. And the other vertical asymptote is x equals 3, and here it goes towards 3 but doesn't actually touch it. And here it goes towards 3 but doesn't actually touch it. Then you're going to find your end behavior, which is how the function behaves as it approaches infinity. So as x approaches -infinity, y is approaching 0. Then as x approaches 5, y is approaching -infinity. Then and positive infinity, it approaches -infinity and infinity. Then as x approaches infinity, y approaches 0. And then as x approaches 3, y approaches infinity and -infinity. So I have one more that I'm going to do, and it is x plus 4 over x plus 3. So first you're going to find the x-intercept, and again you just look where the graph crosses the x-axis or touches the x-axis. So in this case it is -4, 0. And then you're going to find the y-intercept, which is, you're just going to, in this case, just look where it crosses the y-axis, which is at 0, 1.3 repeating. And there are no holes because the numerator and denominator do not share any factors. So then you're going to find the domain. So it starts at -infinity and then goes to 3, but does not touch 3. Then it goes from 3 and goes to infinity. And then you're going to find the range. So it starts at infinity and goes to 1 but does not touch 1, and then goes from 1 to infinity. So then you're going to find your asymptotes. So for vertical asymptote, there's only one, and you're just going to look where the function reaches but never actually touches, and that is x equals -3. So you can see here it goes towards -3 but never actually touches it. It goes towards -3 but never actually touches it. Then your horizontal asymptotes, you're going to do the same thing, just look where it reaches but doesn't actually touch, and that's going to be y equals 1. So here you can see it's going towards 1 but never actually touches it. It's going towards 1 but never actually touches it. Then you are going to find your end behavior. So as x approaches -infinity, y is approaching 1. As x approaches -3, y is approaching infinity and -infinity. And then as x is approaching infinity, y is approaching 1. So that is how to find key features by looking at a graph.